In this video, we're going to be looking at concave mirror formulae, but in a complex version. So, here is our scenario. We've got a concave mirror of focal length 10 centimeters, used to produce an image on a screen that is half the size of the object. We've got to find the position of the object and the image. And finally, in B, if you wanted to produce a real image twice the size of the object, where would you place the object and where would the image end up being? Okay, so let's find the object and the image position first. So let's put down what we know. We know that our focal point is 10 centimeters. Our scale factor in this case is 1/2. We've got to find the position of the object and the image. So use the scale factor formulae. Okay, m equals v over u. Now I know what m is, which is 1/2, and I know v over u. So what I'm going to do is I'm going to rearrange to make v the subject and take u to the other side. So v equals u over 2. Then I'm going to use my inverse rule, which we've got here. But I'm going to substitute in v that I found earlier so that I make it the whole equation to all about u. So I know f, which is 10 centimeters. But let's just solve the right-hand side first. So I get 1 over u over 2, which when put correctly can be 2 over u plus 1 over u. So I get 1 over 10, which is the focal point, equals 2 over u plus 1 over u. So 1 over 10 equals 3 over u. Now I cross multiply. This puts u on the top and allows me to find the object distance, which is 30 centimeters, 10 times 3. Great. Okay, so let's use this to then find the object. The image, sorry. So in this case, I'm going to just substitute it straight back into the formulae. Okay, although you could use m equals v over u. So I've got 1 over 10 equals 1 over u, v plus 1 over 30. I rearrange the formulae to get the fractions. I get 1 over v equals 1 over 15. I inverse it, so the position of the image is 15 centimeters. It's positive, therefore it's real. So let's find the new object position for B. So remember that we've now got m, which is double the size. So in this case, we've got m equals 2, u and v have got to be found, and f equals 10. Okay, so we use the same formula, but in this case it's 2, not 1/2. I'll rearrange to make v the subject, and then I'll substitute that into the inverse equation. So there's my v. I'm going to substitute in for v. So I get 1 over f equals 1 over 2u plus 1 over u. So I make the denominators the same in both the fractions. So I multiply the last fraction by 2. So I get 1 over f equals 1 plus 2 all over 2u. So now I get 1 over 10 equals 3 over 2u. Let's cross multiply. So 2u is going to be 3 times 10, which is 30, which means that u comes out at 15 centimeters. So that's 15 centimeters from the mirror the object's got to be placed. Okay, if you remember, that's the opposite than what we had earlier where we were calculating v. Now that we're going to calculate our new v position, so I'm going to substitute my value for 15 in for u. Take it to the other side, so we'll get, there we go, equals 1 over v. Then I solve the equation, so I get 1 over v equals 1 over 30. Then I inverse, and as a result, v will equal 30 centimeters. Because it's positive, it also means that my image is now real, so I fulfilled the question. So to get double the size of the object, we need to place the object 15 centimeters from the concave mirror, and this produces a real image 30 centimeters in front of the mirror. Okay, thanks for watching.